Our example is the position of moving a car at a time t is given by f of t equal to at square plus bt plus c for t greater than 0, where a, b and c are real numbers greater than 1. Then the average speed of the car after the time interval t1, t2. Then the average speed of the car over the time interval t1, t2, close interval of course, is attained at the point. The options are: first option A into t2 minus t1 plus b. Second option t1 plus t2 by 2. Third option t1 minus t2 by 2. And fourth option is 2a into t1 plus t2 plus b. We shall find out derivative of ft. F dash t equal to 2at plus b, and derivative of c is 0. Therefore, f dash t equal to 2at plus b. Now, over the time interval t1 and t2, we shall find out value of f of t2 minus f of t1 divided by t2 minus t1. We shall try to calculate this value. F of t2 minus f of t1. F of t2 is a t2 square plus b t2 plus c minus f of t1 a t1 square plus b t1 plus c divided by t2 minus t1. Now we shall collect the like terms. We can take a common from first terms and get t2 square minus t1 square plus b common from second terms t2 minus t1, and c minus c get cancelled divided by t2 minus t1. Now t2 square minus t1 square can be expressed as t2 plus t1 and t2 minus t1. Therefore, we can take t2 minus t1 common from both the terms, and that will cancel from the term in denominator, that is t2 minus t1. This becomes a into t2 plus t1 plus b. This term is equivalent to, this is also f dash t. If you take limit of t tends to 0 of this, you will get f dash t. Therefore, this value must be equal to f dash t. A into t2 plus t1 plus b equal to what is given? 2at plus b. From both sides get cancelled. Then there remains a into t2 plus t1 equal to 2at. Again a will get cancelled, and we will get t equal to t2 plus t1 divided by 2. This is the point where our next problem is the two families with 3 members each and a family with 4 members are to be seated in a row. In how many ways can they be seated so that same family members are not separated? Options are: first, 3 factorial cube into 4 factorial. Option second, 2 factorial into 3 factorial into 4 factorial. Option third, 3 factorial into 4 factorial cube. Option fourth, 4 into 3 factorial into 4 factorial. Now, we are given that there are 3 families. Family 1 with 3 members. Family 2, 3 members suppose. And family 3, 4 members. These are the 3 families. And these members are to be seated in a row so that same family members are not separated. That means family should not be separated. Therefore, here we have to do 2 events. First event is arrangement of the family. 3 families can sit in 3 factorial different ways. 3 families can sit in 3 factorial different ways. Here we have to use permutation. Then internal arrangements. Members of family 1 can be sit in 3 factorial ways. Members of family 2 can sit in 3 factorial ways because they have three numbers. Members of family 3 can sit in 4 factorial ways as they are 4 real numbers. And therefore, favorable outcomes or favorable ways equal to, as we have to use all these sum events, we have to use the multiplication principle, that is nothing but 3 factorial into 3 factorial into 3 factorial into 4 factorial, that is nothing but 3 factorial cube into 4 factorial, 3 factorial cube into 4 factorial, and the correct option is 1. Our problem is the area in square units of the region A equal to set of all ordered pairs x, y such that mod of x plus mod of y is less than or equal to 1 and 2y square greater than or equal to x is. Options are first 1 by 3, second 5 by 6, third 1 by 6 and fourth 7 by 6. Now regions are given as mod of x plus mod of y is less than or equal to 1. Therefore, we shall draw a square. What is mod of x plus mod of y greater than or equal to 1? That is a square with vertices 1 on each axis. And 2y square greater than or equal to x, this is a parabola. Y square is equal to mod x. Therefore, it is a parabola to both the sides. And we have to calculate this region, shaded region. We have to calculate this shaded region. Now, this is the origin O, 0, 0. This is A, 0, 1. This is B, 1, 0. Now, we shall find out area of the triangle OAB and subtract this area from that area of triangle OAB, so that we will get area of shaded region first quadrant. And as this is a symmetric, the area, total required area is 4 times this shaded region's area. Therefore, area of triangle OAB, it is a right angle triangle, see, having sides OB1, OA 1 unit, and therefore area of triangle is nothing but 1 by 2 into 1 into 1, that is 1 by 2. Now we shall find out this point of intersection. This point of intersection, for that we shall solve these two equations. 2y square equal to x, and this is x plus y equal to 1. X plus y equal to 1 and 2y square equal to x. If we solve these two equations, what is x? X equal to 1 minus y. Put this x equal to 1 minus y here therefore 2y square equal to x, and that is nothing but 1 minus y. Therefore 2y square plus y minus 1 equal to 0. Its factors are 2y minus 1 into y plus 1, and this is equal to 0. This gives y equal to 1 by 2 or y equal to minus 1. In first quadrant, y equal to 1 by 2 is this is the value. As y equal to 1 by 2, x is nothing but 1 minus y. Therefore, this point is 1 by 2, 1 by 2. I draw a perpendicular from this point on x-axis. This point is 1 by 2, 0. This region, suppose this is R1 region, this is R2 region. Then we shall find out area of R1 equal to 1 by 2 into 1 by 2 into 1 by 2, that is nothing but 1 by 8. Area of R2 equal to 1 by root 2 integration of root x dx from 0 to 1 by 2. X means from 0 to 1 by 2. And if you evaluate this integral, you will get 1 by root 2 into x raised to 3 by 2. That is x raised to into root x square by 2 within the limit 0 to 1 by 2. This can be written as 2 by root 2 into 3 into 1 by 2 into 1 by root 2. Root 2 get cancelled. 2 into root 2, 2 into 3, 6, 1 by 6. Therefore, area of this region R2 is 1 by 6. Area of region R1 is 1 by 8. And this area of the triangle is 1 by 2. Therefore, area of shaded region in first quadrant equal to 1 by 2 minus 1 by 8 plus 1 by 6, that is 1 by 2 minus 6 plus 8 by 48, that is 1 by 2 minus 14 by 48, 1 by 12 minus 7 divided by 24, 5 by 24. 5 by 24 square unit is the area of the region, shaded region in first quadrant, and hence required area equal to 4 times area in first quadrant. That is 4 times 5 by 24, that is 5 by 6 square unit. 5 by 6 square unit, it is second option. This correct option is option 2, that is 5 by 6. We shall solve the problem. The region represented by z equal to x plus iy in C such that mod of z minus real part of z is less than or equal to 1 is also given by the inequality. And we are given 4 inequalities. Y square is greater than or equal to 2 times x plus 1. Y square is less than or equal to 2 times x plus 1 by 2. Y square is greater than or equal to 2 times x plus 1 by 2. And y square is greater than or equal to x plus 1. Which inequality is correct? We have to find that. Z equal to x plus iy. Therefore, mod of z is nothing but x square plus y square under root. Therefore, it is the given equation mod of z minus real part of z less than or equal to 1. This equality becomes root of x square plus y square minus real part of z is nothing but x is less than or equal to 1. Therefore, root of x square plus y square is less than or equal to 1 plus x. If we square both sides, we will get x square plus y square is less than or equal to 1 plus x bracket square, that is then 1 plus 2x plus x square. X square get cancel from both sides, and y square is less than or equal to 1 plus 2x, which can be expressed as 2 common x plus 1 by 2. Therefore, y square is less than or equal to 2 times x plus 1 by 2, and therefore second option is correct.